This time, let me show you a sample implementation of stack in Python. We have in here a package stack, and we know that this is a package because we have this initialization Python file, and we have here 1, 2, 3, 4 Python modules or Python files with a .py file name extension and stack sample here. In stack 1 Python module, we define a class stack. Now recall our lesson in Java. A class is a representation of an object, and in here we define the fields and the methods for the object stack. And we have here methods such as isEmpty that returns true if the stack is empty and false otherwise. And how do we do that? By using the built-in function len, which returns the length or the number of elements inside this list elements. Okay, so we have here one class field elements, which is a list, and that is initially set to empty. It has no elements yet. So the stack is initially empty. And to check if it is empty, we simply get the length or the number of elements of this list elements. So if that is equal to 0, then it is empty. Pick returns the element at the top of the stack without removing it from the stack. So if the stack is empty, it would return none. So there is no top element of the stack because it is empty. And if it is not empty, then it will get the size of the stack of the elements, this one. So another way of determining the number of elements of stack is calling the method size, and it would return the number of elements and then -1 because by default the index starts with 0, just like in an array. So take note that elements is just like a one-dimensional array. So the index starts with 0. So the number of elements -1, that is the index of the topmost element. And the size here would return the number of elements inside this list elements that contains all the elements of the stack. We call in here, this is the method call of this method size. And to push an element or this new value into the stack, we simply call the append method, which is a built-in method for list type objects. So the new element is value. So this stores the new element value at the top of the stack. And pop will remove the element at the top of the stack and return it. Take note, it will remove the element at the top. It will remove the top element and return it to the caller of the method pop. So what's the difference between pick and pop? Pick will simply return the top element without removing it from the stack, while for pop, it removes the element at the top of the stack and then return it. So the value of top in here will be decremented, just as we discussed in the previous lecture. Now, how do we implement the pop method? First, we check if it is empty. If it is empty, then we display, prompting the user that we cannot pop because the stack is empty. And then we return none, no value at all. Else, if it is not empty, then we use this built-in pop method for list type to remove the top element and return it to the caller. Now, stack 2 is the same as stack 1, except that we add this method is in stack. So this would return true when the value is found in the stack. And for that, we use the in keyword. If this value is in the elements of stock, then we return true. Otherwise, this returns false. So that's the only addition that we have here in stock 2. Let's now go to this module, Python module. This is like the equivalent of the import statement in Java. We specify from where are we going to import, and we are going to import the stock class, which is this, from stock1 module. Since stock1 module is inside package stock, we have to specify the package. So the syntax would be from package dot module import the object. So the object could be a class or a variable or any object in that module. And then we instantiate the class stock, creating the instance S1. So S1 here is an instance of class stock. We could then access all the fields and methods of class stock via the instance S1. So we say S1.push, or you could say S1.isEmpty, S1.pick, S1.size, S1.push, S1.pop. So just like in our lesson in Java, when you create an instance of a class, via that instance, you could call or access all the fields and methods of the class. So if this is our stock, the first we push is 1, right? So we have here 1. And this is our top. Top is equal to 0. Next, we push 2. And this would be 2. So top now is equal to 1. And then we push 3. Top now becomes 2. And then we push 4 here. So top now is 3. And lastly, we push 5. So top now is 4. And then next, in the code, we print stock elements. So we have here the output stock elements. And we use a while loop while not S1.isEmpty. While S1 is not empty, we pop and print that value, which is popped out from the stock S1. So this is not yet empty. So first pop is 5 and we display 5. And then next, it's not empty yet. So we pop again and display 4. Next, we pop again and display 3. And then pop again, display 2. It's not empty yet. So pop. Take note that every time we pop, we decrement top. Okay. So display 1. And your top now becomes negative 1. This would indicate that the stock is empty. So as you can see here is empty. When there are no more elements, then the stock is empty. So this is your elements 0. This is elements 1, elements 2. This is elements 3 and elements 4. Okay. Element 0 is 1, element 1 is 2, element 2 is 3, element 3 is 4, element 4 is 5. And so the first element to get inside is the last element to get out. The last element 5 to get inside the stock is the first element to get out. First print or first out, and this is last out. So recall again that stock is a last in, first out structure. And the last print here is to display the type of object or instance S1. And as you can see here in the output, it says that S1 object or instance is of class stock, that's stock1 stock. So it is class type stock, which is defined inside module stock1, which is found in package stock.